So welcome to our last part of Chapter 2, Application Layer Protocols, the little helpers we need in the internet to run the big applications like browsers, the web, email systems, etc. So Snmp. Snmp, a simple network management protocol. So we are talking about network management, why we need this, etc. and how it works. So first of all, a bit of a motivation, an overview, and then managed objects. What is this? Some operations, the protocol, how it works, some easy tools, and a bit about newer developments before we wrap up the whole chapter 2. So what is the problem? Well, as soon as you start a network, you may run into problems. Why? We have many components with a lot of different configurations. We have many users, we have a lot of different software versions, etc. Servers, switches, routers, backbones, etc. So the problem is, what happens if a user says, well, somehow there's a problem. So maybe it's somewhere in the network, we don't know. So basically, the user asks the administrator, oh, please can I have a look? Or you start a trouble ticket saying, well, computer is slow, something doesn't start, or I don't have access to whatever application. Then the problem for the administrator is, well, is it a host problem? So maybe wrong software, old version, not updated, whatever, misconfiguration. So no one knows that maybe it's just a broken cable or someone just cut the cable or whatever. So we don't know. So it could be also weird behavior of a switch. So maybe there's a bug or the device is old or whatever. It could be also a proxy that is misconfigured. You remember proxies for the web, maybe a misconfiguration. We don't know. Maybe wrong software, something like this. Or maybe it's one of all the other boxes there. So maybe something is out of service, some interface is not running, etc. Maybe it's also a cable issue there. So we don't know. Maybe it's somewhere in this large networks, we may have hundreds of components, so maybe it's not reachable. So we don't know. So we need at least some tools for remote diagnostics. We need statistics. We have to check devices. We have to get automatic information, how many packets per second, for example, leave a certain interface. And if we see, for example, everything is fine here, everything is fine there, in all directions, then maybe this device is okay. But maybe if we ask this switch, the switch will immediately tell us, well, 0 packets received from here. So then we know, okay, maybe there's a problem with the port, but maybe also there's a problem here with the line, the wire. So we need tools to check what's going on. But we also need maybe tools for planning. So statistics telling us, well, okay, there's a component that's completely overloaded because there's too much traffic going on over this component. Or maybe there's a problem, so we should have another connection across the campus, something like this, reconfiguration, extending networks, replacing components, etc. So definitely we need a management tool. So what kind of functionalities do we need? One is called performance management. That's quite obvious. That's exactly what we need. For example, here what I showed, okay, there's a broken cable. So we measure, we analyze the network, the performance, and then we see, okay, there's a link that doesn't receive anything, or a link is down or whatever. So we measure the throughput, we measure response times to check if we have overload in certain services. We check the load on a link so that we can tell, okay, if the average load is above 60%, we need an additional link, for example. So that's quite important. But then also we have to manage the configuration, Because imagine a normal company network, campus network of university, you have thousands of devices connected. And if something happens, you should know what is the configuration on this specific device. Maybe old software, maybe strange hardware, maybe the user changed something or whatever. So if a user says, oh, I have a problem, we need additional information like, okay, what type of computer, what type of operating system, what application, type of network interface, etc. Is it wireless or is it wired, etc. So that's extremely important, configuration management. And maybe we also need a tool that helps us to modify the configuration. So that we say, okay, there's this old software now, let's install a new version, something like this. Then also we have to account many things. The utilization of the network, bytes used over this link or whatever. So we can say, okay, this group, well, maybe uses a bit too much of the network, or you have to pay something. So we have to check what's going on. So if we charge for it or not, it's quite important to see, okay, what is the network utilization? Fault management. If something happens, well, we want to have automatic notification. We need logs, many logs, so we can check logs automatically, manually. We need certain automatic mechanisms to notify users, and maybe also some mechanisms to automatically fix problems. That would be nice. But at least we need tools to detect issues. And then extremely important, security management. So who is allowed to access what part of the network? Yeah, we can do all this manually, but this is error prone. This is really a problem. It takes a lot of time. So it would be much nicer to say, okay, we have a more general management platform, and with the help of the platform, we can control the access to network resources. We can implement certain guidelines, so that also we protect the network from intentional, unintentional sabotage, and we have to protect certain sensitive information, etc. So that's a part of the functionalities we need for our management system. So, and that's really, all these functions are vital for network operators. So 2 examples why we need this and why many networks are bit larger than what you're used to and maybe your home network. One example from the region where I'm from in Germany, southwest part in Baden-Württemberg, and there you have a university network shown on the left-hand side. You see that certain cities like Karlsruhe, for example, connected to Stuttgart. So you have a kind of a topographical view, and you see, okay, here we have so-called dark fiber, and we have certain leased lines, etc., etc. So who's connected with whom? So that's interesting to see the infrastructure. But what is a bit more interesting for the network operators is the view you have in the middle, where you see the cities of, in this example, Karlsruhe and Stuttgart, and you see, okay, we have several hundred gigabit per second links, and we have some additional 100 gigabit links or 50 gigabit per second links, etc. And you also see the connections to commercial exchange, DE-CIX, and some others here, some commercial so-called upstream connections to German Telecom and to other networks. So you see the topology, the capacity of the links, the connections. So this is good for visualization, who is connected with whom, and if we have a problem with the links, so then we know, okay, here between this and that, whatever, Villingen, Schwenningen and Trossing, then we have a problem here somewhere between the Black Forest and Schwäbische Alb and whatever. What is more interesting for, everyday work is here where you see the links, again, the links, how they look like. If everything is green visually, that's fine. Okay, between Karlsruhe and Stuttgart, you see everything is green, light green, dark green, that's nice. If we see red lines, that's not a good idea, but this gives you an immediate feedback about the health of your network. There are many more alarms and logs and whatever, so that helps the network administrator to see what's going on. And you can imagine for such larger networks, it's impossible to do many things manually. So you have to have a lot of automatic systems. Another example that tells you why we need network management, you cannot handle manually the sheer amount of traffic. This is the traffic load at one of the largest exchange points, DE-CIX in Frankfurt. And you see that this easily hits around 9 terabit, 10 terabit per second. So this is really a lot of data crossing these exchange points. So you see at that time that peak was already beyond 10 terabit per second. So there's really a lot going on, and you need not only the statistics to make these nice graphs, etc., but also you want to see how many erroneous packets are there. How many problems do you have per second, indicating that there's something strange going on certain links. This is also important to detect automatically denial of service attacks. So if there's suddenly a strange peak somewhere, this might be indication for either researcher downloading a lot of data from the CERN, for example, or there might be some denial or dispute denial of service attacks if that there's a lot of traffic coming in from certain regions over several links, etc. So there are certain indications. Okay, so what do we need? So we absolutely clear we need network management tools. So what do we want to have? Okay, we want to monitor our equipment. So we want to see what's going on a router, on a switch. So if this is green, orange, red, whatever, what's going on a printer, on a device, on all different devices, network access points, hotspots, etc. We need statistics to see if a device is overloaded on the average over a longer period of time, then we have to replace something. And if something goes wrong, we need tools for diagnostics. So we have to basically, we need a simple tool that allows us to go on a device and to check what's going on. But now already we see maybe a problem. Oh, there are many different manufacturers of devices. What do? They're all different. And maybe many of the devices, they come with their own tools for management. So some with web interfaces, different browsers, some already have apps and this and that. Okay, and we need a lot, we have a lot more goals. So network status, simple models, also planning. Yeah, so because sooner or later someone wants to see, okay, what do I get if I spend a certain amount of euros in it? What is the plan? So we can also simulate new networks using the current load. So we can create traces of the current load. Then we can simulate what happens if we have different network topology. Do we have less load on central nodes, etc. So there are many things we need for network management. And so let's just jump right in the middle. So for example, if something goes wrong with a DNS system, network management hopefully tells us, but we also need DNS for certain network management. So you see, maybe if something really goes wrong, also some of the network management tools will not work anymore, or will they? Well, it depends what they need. So telephony, for example, that's also something we need for network managers. So they call each other, so what's going on? But because it's IP telephony, we better make sure that it really runs. So many devices, parts of the infrastructure that require network management. So what's going on with routers and switches and servers? So what about the buffer status in one of our core routers? Who is allowed to use what kind of data rates somewhere, etc. But also, what about certain services? Who's allowed to use them on certain devices? So, yes, this is what we all want, but one of the problems is it's heterogeneous. So, all the systems, they may use different ways of describing the buffer fill size, the CPU, so many percent used of a CPU for certain processes, etc. So how is this stored? This might be different ways of structuring, different syntax, different semantics, etc. Plus, we all want to access this remotely over existing network. Yes, we know if the network is down, we cannot do this, but let's assume for now we have at least kind of a core network, so IP is running, so we need something on top of IP that helps us to do all this diagnosis, statistics, monitoring, supports us for planning. And then also something is quite important. All these ideas, well, many engineers had them already many years ago, before we had the web and apps and all this fancy stuff with XML and HTML, etc. So those ideas are a bit older, from the 80s. Okay, first of all, some overview. You remember email? So it looked pretty similar. So we need also here certain simple building blocks for network management. Okay, so what do we need? We need a protocol to access the data, Snmp. Again, you see, simple network management protocol. You remember SMTP, also a simple protocol basically to transfer emails. Here we have Snmp. So we have a protocol that specifies how we access management data. Okay, so now we need some storage structure, and that's the management information base. Not Man in Black, but that's the database. So, and this is where we actually, well, store our things, this database, plus the meaning of the elements we store. We will see some examples, which data can be accessed. So, for example, if a router has no mechanism, no hardware, whatever, no software, no drivers to access the buffer fill status, then this cannot be reflected in the management information base. But if the router manufacturer has all the capabilities to read out the buffers, just for example, then this information can be stored in the management information base. And then we need additionally some ways of describing the content. So some structure. So for the management information, we need a structure, and we need a notation for the syntax. We'll come back to this. What does it mean? Well, the problem is, as I mentioned, the devices can be very heterogeneous. We have many different manufacturers of the devices. So all the manufacturers could potentially describe, for example, buffer fill status or whatever in completely different ways. But we need a common syntax and a common way of describing what we mean, so that if we access the information from a machine, from a certain vendor, and we want to read the buffer fill status, we will get back the buffer fill status and not the CPU cycles currently used for a certain process or whatever. So we need rules, we'll see them, to define and to identify data. Okay, so let's start with Snmp. So Snmp, simple network management protocol. Again, this is how it started, so very simple, easy to scale, not many fancy features, and a bit similar to email. Many thought, okay, the official big versions from ISO with their standardization about management, etc. This will come, but in between we will have this simple thing. Well, similar to email, it came simple and it stayed here, as always. So, Snmp for management of devices and services use simple datagram service UDP. So nothing fancy, so we can use UDP. So that was the idea. And then there's also a network management framework that's defined with Snmp. What do we have there? I will show you an example of it. It's a classical client-server architecture. Okay, but in this case, you know client-server already, so we have many web browsers, our clients accessing our huge server. So that's the idea of the web, classical. Here it's different. We have many servers, and those servers, they run on the devices, like a printer, like a switch, a router, a computer, a whatever device. So many servers. And now we have a client, and the client can access those servers. That's the idea. In Snmp speak, the servers here are calling our agent. That's the agent, and the agent is a process that runs continuously on so-called managed nodes and collects information about the device. So, back to our buffer fill status, this agent then would collect, let's say every second, every 10 seconds, whatever, what is the status of certain buffers, and stores this in the management information base on the server. So the agent runs on the server and stores the information. On the client, you have the manager. So the manager basically is our network management platform, and this is the manager asking for certain information that the agent stores in a management information base. So now we have the situation that you have few clients, maybe only one client, the network administrator, contacting thousands of servers. On the servers, you have the agents running those processes. They collect all the data from all the ports, for example, from the CPU, the operating system, etc., and stores it in the management information base. And then the manager can access it. Additionally, you have in the framework of Snmp, you have so-called proxy agents. So it could be that you have non-Snmp capable systems, legacy systems or whatever, so strange hardware, and then you could have proxies that integrate these non-Snmp systems with then proprietary software, but offers then all the information and behaves like a Snmp capable system. That's the idea. So these are the parts, agent and manager and a proxy, but agent and manager, that's the important part. Additionally, Snmp also describes the information, the management information. Okay, how does this look like? Well, so you have to say how actually does do in the end all these pieces of data you collect, how do they look like? How do I access them? I also have to access the Snmp protocol. I have to specify packet formats. We'll come back to this in a second. But first of all, we have to describe our information, and there's something that's called structure of management information. And SMI specifies certain rules, and those rules, they describe how we structure the monitored information. And that SMI also describes the format for those objects and SNMP, the protocol, accesses those objects over the network. You will see in a second on some slides some examples. So that is the idea. So for example, if you say, okay, you ask a router and the router has an integrated temperature sensor, how warm is it in the room, how warm is the processor, etc. That sounds simple, but think of maybe this is a very simple controller in the router, very simple thing, just a 16-bit CPU, or is it a 64-bit CPU? Is it little endian? Is it big endian? So basically you have to know the structure, the format of this piece of information. Otherwise you will not be able to interpret it. So you will just get some bits, and is it big, is it little endian? You don't know. Okay, we'll come back to this. Then you need the information base. So it's a data storage, and this describes how you store all these so-called managed objects. So managed objects could be the buffer fill space of certain ports of a router. We'll see that there are standards for it, and you can also have private, proprietary management information bases. What does it mean? So the standards describe, for example, how do I access certain things with IP protocol, but they do not describe how a certain manufacturer of a certain device then describes the certain object for this very specific network adapter. So we need a way to describe this management information. And we need a place where we store it. And we see how we use a real hierarchical structure for storing this. Yeah, and then we have to access it. So if we know how we describe it and we know where we store it, we need a protocol to access this information. This is then in the end SNMP. So yes, SNMP is also this whole framework. So with SNMP, there are many more standards so attached to. So we have to all this describing the information, etc. But then we also have the real protocol. And this protocol then describes the format of the messages, the PDUs, the packets exchanged, but between the management system and the agents, and describes also basic operations. We'll see what they are: get next, set, and trap. Very, very simple, as we will see. So this all started in the 80s. And in the 80s, SNMP version 1, that is the original standard. And this really was an interim solution because at the similar time, ISO, together with all this layering, started defining protocols called CMIP, that is Common Management Information Protocol and Common Management Information Services. And yes, they work, but they are a bit more complex. And they are used in rather these telco devices, these huge telco networks, etc. Not with the internet. And so we have a similar situation as we had with SMTP and X400, the email system. Yes, there's X400 with many more features, but SMTP, that's the system we use in the internet. So very simple system, but very successful because it was very simple. What was one of the problems? Weak or no security. So SNMP version 1, there was no way of really having user-based security, for example. And I also remember that some of the routers they had a real key, real mechanical key and a lock, and you could really lock the router so that SNMP, remote SNMP, was not possible anymore. And you had to unlock it to enable SNMP. So because everyone knows what happens if you do some misconfigurations at core routers. Okay, so we had some more problems with SNMP version 1, for example, so-called bulk requests. As you will see, to get bulk of information. So for example, give me all the parameters you have stored about this interface. You have to send many requests. We'll see this. But maybe what is needed is give everything. And I just want to send a single command. This has been solved as SNMP version 2. That's also quite, well, the SNMP version typically supported by most devices. And there are some enhancements, especially around security and around this bulk operation. The current version is version 3. And here you really have advanced security models, so not only logging in and then you can send your requests, and the old versions even you had the password in clear text and all the requests, all the messages, then they didn't have any security parameters. And now with version 3 we really have advanced security, so all the messages now have the security parameters, and so we can guarantee confidentiality, integrity, and authentication. So this classical CIA triad you learned in the bachelor courses. So basic security, great. So SNMP version 3, that's the version you should use if you go for SNMP. Okay, so we see there's also some history, but how does it work? Example. So let's assume we have a very, very, very simple network with only 3 devices. We have somewhere our server, we have a printer, we have a PC. On all those devices, you have a software process, our agent, up and running. So you have this agent, and this agent talks SNMP. And if the manager wants to access some information here, the manager then asks the agent. That's the idea. So you integrate an SNMP agent, and this agent maintains then all this management of data, collects all this, how many packets did I drop and receive, etc. And the simple SNMP based on UDP, so very simple. If it doesn't work, just repeat it. And so one of the questions is, so why not using HTTP instead of SNMP? If you buy a printer today, you always have a web server up and running on your device. Well, yes, this is the case. Many devices nowadays. The point is, 80s, SNMP started in the late 80s. There was no World Wide Web. There was no successful HTTP, whatever. That's one reason. And logging onto a server, printer, whatever device with the help of HTTP, so your browser, this is fine for your printer at home. Then you have a nice web page and you can manipulate everything. Great. But imagine a normal university campus network with 10,000 and more devices. No one logs into these devices using web browsers. You need simple protocols that are suitable for automation. So you have to write scripts and scripts interacting with this to collect information across all these thousands of devices, for example. So that HTTP simply that doesn't work this way. We will see how we can use HTTP later. So SNMP is more appropriate to address this large network. Okay, we still have an open question. So what do we exchange? These are our managed objects. That's the content, and we will see how this looks like. Before we do so, some more general questions. So think again, what are the basic goals of network management? We have some short-term goals, maybe some very, very urgent, ultra short-term goals, maybe mid-term, maybe also some long-term goals. What could this be? And think of network management, very general way, which components do we need? What is needed for network management? So who needs what and what do we want to do with it? And then we have this agent in Snmp. What is this agent responsible for? What is an agent in this context?